Algebra benchmark 8-2, graphing quadratics. First problem is set up nicely for us so we can find the zeros, or the x-intercepts. We have at 2 and at positive 5. That will make the height, if I make this y 0, 0. So in other words, xy table. If I want my y value to be 0 to make those, to get the intercepts, I could do this. So at 2, 0 and 5, 0 are my x-intercepts. And then our line of symmetry would have to go through the middle of that. So I know our vertex is on that line of symmetry. So I'll just draw a quick little dotted line there. If you go halfway between the 2 and the 5, we have 3.5. So if I plug in the 3.5 into our equation, erase this, I get the opposite of 3.5 minus 2, 3.5 minus 5. This gives me negative 1.5 times negative 1.5 here. And that is positive 2.25. So y equals 2.25 when x is 3.5. So if I go to the ordered pair 3.5 and then up 2.25 basically, just estimate that dot right there, that'll be my parabola vertex, and it looks like it's opening down. And probably one more significant point we probably should get is the y-intercept, and that's when the x is 0. So going back over all this, we plug in 0 for x here and there. So we get y equals negative 2, negative 5. That's 10 with a negative out front, so negative 10. So 0, negative 10 is my y-intercept. And then I'll just use symmetry to figure out the point on the other side. So if I just go 1, 2, 3.5, half, 1, 2, and 3. That gives us a pretty good idea of what this parabola is going to look like. And then the next one, y equals negative 1/2 x times the quantity of x plus 8. I'll do the same thing for the zeros. I want to make this 0. So if I let x be 0 here for that spot there, well, for both spots, then I get 0 times 8, which is 0, so that works for my height to be 0. So at x equals 0 is one intercept. And then here, to make that 0, I need x to be negative 8. So if I put a dot way over here at negative 8, and then again figure out our line of symmetry, 1, 2, 3, it's 8 there, so 4 down, for the line going down, where the 4 is, negative 4 is. And then we need to find our vertex on that spot, so we need to plug in that negative 4 value to figure out where that falls. So I'm going to plug in y equals negative 1/2 x, which is negative 4, times negative 4 plus 8. That's 4. And then this is negative 16 times negative 1/2 is 8. Or if you just want to do half of 4 is 2, and then negatives cancel. 2 times 4 is 8. So my y value at that point is 8. So at negative 4, I go up 8. There's my vertex. Again, it opens down, and I know that from the negative out front of the problem. Just like before, I had a negative out front there. And then I think that's good enough. We probably should get one more point somewhere. We already have the y-intercept here. So whether you want to go further down to the right, I'm just going to pick a point up in the, in the negative side here. So like maybe negative 2, and just figure out where along the line here, somewhere along there, that point it falls. It's going to fall in here somewhere. Let's figure out where it is. So I'll do the same process and plug in negative 2. So I get y equals negative 1/2, negative 2, negative 2 plus 8. I get 6. This is 1. So 1 times 6 is 6. So at negative 2, I go up 6. And then I can just use symmetry instead of plugging in another value. Instead of plugging in negative 6, I'm going to get the same answer. And that gives us a pretty good idea of that parabola. All right, let's get this out of here. For the last problem, I'll use green. We need to factor that problem first. I see that I can take out a 3 right away. I'm going to write it up a little bit higher here. So if I take out a 3, I get x squared minus 2x minus 3. And then I can factor that a little bit easier with that 3 out. This has to be a 3 and a 1 to multiply to give me 3. 3 and a 1. And 1's got to be positive, 1's got to be negative. It's going to be the negative 3. So this is negative 3 here with my smiley faces, and a positive 1x. When I add them, I do get my negative 2x, which is my middle term, and that's what I was looking for. So then my intercepts, looking at that problem, would be positive 3 and negative 1, the opposites of those quantities, to give me 0. So positive 3, negative 1. And then our line of symmetry, 1, 2, 3, 4, so it's 2 in there. So my line of symmetry has got to be at 1 somewhere. So I can plug in that 1 for x, either in my original problem or in my factored problem. I guess I'll use, I think it might be easier with my factored problem. I'll plug in 1 right here. So get y equals, when x is 1, 3 times 1 minus 3, and 1 plus 1. So negative 6 times 2 is negative 12. So at 1, I go negative 12. It's off my screen here. I can just estimate it down here. And then probably one more point, which in this case I'll use the intercept. In this situation, the intercept is easier found in this format, where I can plug 0 in for x here and 0 in for x there. They cancel, or they're gone. So I just have y equals the negative 9 at the end. So 0, negative 9. And I'll use symmetry to get the other point. Just off 1 there, and then connect the dots. It's kind of a skinny parabola. And now we have our 3 parabolas.